Hi friends, welcome to our channel. Let's have a look at problem 3641, longest semi-repeating subarray. In this video, we are going to solve it using two-point sliding window method. So here the problem statement is very short, right? So let's quickly go over it. So we are given an integer array called nums of length n and an integer k. So a semi-repeating subarray is a contiguous subarray in which at most k elements repeat. So we want to find the length of the longest such subarray in nums. So if you look at the examples, for example, example 1, so you can see this is 1, right? The length is 6, also the longest. So the constraints are the following. First, the length can be as large as 10 to the power 5. In other words, when we do the coding, we need to pay attention to temp complexity. And the elements are positive, right? And the k is in between 0 and the length of this array, right? So with that said, we are ready to explain the main idea. The main idea is this. So once you have a subarray, it must have a end index, right? So based on this, the idea will be the following. So for each right index r, so we want to find the smallest L such that the subarray starting from L and ending at R is semi-repeating. So this will give us a length r minus L plus 1, right? If we can find such a thing for every r, then we just take the maximum. That will be our return, right? So this actually here, for right index, find the smallest left index. So this establishes a function relation between R and L, right? So here we can also have monotonicity. So if the right index it becomes larger, then the left index must also be larger or keep fixed, right? So in other words, if we push R to the right, then we need the L would be at least as large as before, or can be strictly larger, right? So this monotonicity actually is the rationale for using two-point sliding window method, because we don't need to start over of L from the beginning. So with that said, I hope that you can digest the main point. So now let's look at the coding, and afterwards we can also do some print, so you will know the detail. So first, I'm going to have an n. The n is nothing but the length of this nums, right? So I'm going to initialize a result variable, so which represents length. So originally we set it to be 0. So actually for this, it's actually at least 1, right? Because one element is no repetition, but let's use 0. So the window will be a dictionary, right? We keep a window. Also, it's used to check within this window if there are more than key repetitions, right? So then the left pointer is going to be 0, and then in repeated, so the number of elements appears more than once. So originally 0, right? And then for r in range m, so for each right index, so we're going to locate the smallest possible left index, such that from that left index to the current right index, it gives a semi-repeating subarray. And then we get the length, and then we update the result, right? So then first thing, let me get the frequency of this number, right? The window get, right? So nums r. So if the count is 0, no nums r is not a key in window, so we just give it a 0. So if originally you have 1, right? So now you want to add the current element, then you get a repetition, right? So then if original count is 1, then because currently we want to add nums to the window, then the number of repeated is incremented by 1. So then also we can update the nums r. Its frequency will be the original frequency plus 1, right? So this is the update so that we contain the information up to the current right index r. Then we want to find the smallest left L such that within the window between L and R, there's no repetition, no more than key element repeat. So in other words, we want to locate the semi-repeating subarray ending at R. So this is a while loop, right? So while L is less than R. So here I write strictly less. Actually, you can write left less than equal because this condition will not hit, right? So then add n repeated is greater than k. So in this case, we're going to shift left, gradually pop. You can think of pop up the left elements. So here, let's look at the left elements. The element is nums L, right? Let's extract it to make it more clear. So this number, let's look at its frequency. The frequency will be window get the left element, right? Or 0 if it's not. So if the frequency is 2, right? So now I want to pop 1. So then the repeated is going to be updated, right? It's decremented by 1, right? So now we have window, the left element is decremented by 1, right? So now also I want to do some extra step. So if window left element is 0, in other words, there's no. So just delete that window left element, right? So then once you've done this, so it's corresponding to increment L by 1. So once we exit this while loop, so we are going to have the condition n repeated is less than or equal to k from L to R. So this means that we locate the smallest L. So we get the corresponding semi-repeating array ending at R. What we do is this, after this while, so what we are going to do is result equals max, the previous state, and R minus L plus 1, right? So once you have this, so you are going to return the final state of the result. This is the full code for this problem. Let me first run it. Yeah, it passes the 3 test cases. So now let me first test for the generic case. Yeah, it passes all the cases. So now, in order to better understand this, so let's print something out, right? So I'm going to use fstring. So what's the current index? And what's the corresponding left index? And also we want to find the corresponding length, right? The length is given by R minus L plus 1. And the corresponding result, right? So let me write like this. So now let's run it. So if you look at the first example, ending at index 1, the left is 0. In other words, for this itself is a valid 1. Ending at R equals 1. So all these are 0 up to 4, right? So this one. So because here 1 appears repeat, 2 repeats, right? And then if you go to this 3 corresponding to R equals 5, so you cannot include the leftmost 1, right? So your L is shifted to 1, right? But if you go to 6, so you can include the L is still 1. So the length actually is 6. This is also the same. So here, if you look at this one, so the repetition is at most 4, right? So here you have 5. You have just one element appears once repeat, so you get the 5. So you can see the input, right? For all the R's, the L is 0. For this one, so you see, for R equals 0, L must be 0. For R equals 4, L must be 4. So all the length is 1, right? So with that said, I guess we explained the idea and the monotonicity which guarantees the time complexity or the rationale of two-pointer sliding window method. After the coding, we also print out this details for digestion. I guess up to now, you should have a rather complete big picture of this problem. Then I guess what's left is to do some practice by yourself. So with that said, I guess that's it for the current problem. Thank you for watching.